Today we are gonna talk about one of the most common misconception of Node.js. Is Node.js a really single-threaded? Well, I asked this question to all the candidates that I interview, and the most common answer that I have seen is yes, it's a single-threaded language. My follow-up question is, if it's a single-threaded, then how can we achieve concurrency? On the I get answer, oh, it's on the callbacks. I'm like, all right, so where does this callback run? And then they go like, it's on the callback queue. I'm like, all right, I'm not gonna say anything on that. And that's not the answer I was looking for. But okay, so today I thought I'll just clear up the confusion once and explain how the Node.js actually works, and we'll build a very simple event loop in Go and prove you that Node.js is not truly a single thread. So let's get started. Okay, so why do people say that Node.js is single threaded? It's true that JavaScript itself is single threaded and the Node.js event loop runs on a single thread. But Node.js itself is not a single threaded and your async tasks does not run on event loop. I know it's very confusing, but let me explain. Node.js offloads all the async tasks like file read writes, database queries, HTTP requests to the worker threads that runs on the background. So when they finish, their results are stored back or sent back to the callback queue, which is then picked up by the event loop. While event loop runs itself on a single thread, the heavy lifting is done by the worker thread that runs on a separate thread. Let's take a look at this particular image. So here we have event loop in the center and it's checking for call stack, and then it checks for web API and callback queue. So here what happens is when the event loop runs for each tick, it will check if there's call stack that can be used. So here console log A will be logged first, but as soon as it will find let's say this logger is an async operation, that will be sent to the callback queue, and once the operation is done on the background, it will be sent back to call stack, which will be picked up by event loop in the next tick. To understand it much better, think of event loop as a restaurant manager. So restaurant manager is not responsible for cooking the food. He is responsible for taking an order and delivering it. So what happens is restaurant manager takes the order from the customer, which is the um, function or the callback that is being sent by the customer, and he offloads that to the kitchen staff, which is our worker threads or the callback queue. Once the food is ready, that is sent back to the call stack, which is on to the delivery or pickups table, from where it's picked up by the restaurant manager and is served to the customers. The similar way the event loop works. So let's take a quick example here. So in this main function or this JavaScript code, we have very simple code. We just read a file and log to it. Let's run this. Do node main.js. So in the output you will see we get start and then the file content. So if we take a look at this particular event loop once again, so to understand, as soon as we reach to the console log, it's directly pushed onto the call stack and we get start. Then it is then we reach to this part, which is read file, and it's an async operation, so it gets sent to the callback queue, and once it's sent to the callback queue, it moves on to the next line, which is console log end, and this is picked up directly from the call stack and printed out. So once this is done and the read file is done, which the data is pushed on to this particular call stack again, and we get console log of all the data. Okay, so now let's get started by implementing our own event loop in Go. So let's start by first provide with the package main, and then let's create our task that will only have callback that should get executed when the task is completed. So it will be of type struct, and it will only have callback of function type function. Then we need to simulate our callback queue. So for that we just create a task queue. It will be of type, we'll make it of type channel of task and the size of 10. Then we need to create a wait group where we'll wait for all the worker threads to wait for the finishing of their task. So we'll go with where wg, it will be sync dot wait group. And also we need to create a way so that our event loop does not exist fast. It stays alive until all the task in the task queue is done. So for that we have another function. It will be event loop wait group, and again it will be of sync dot wait group. So we are done with the some of the important parts, like basically the queues that we need. And then let's start by implementing our first event loop. So let's go with event loop, and let's do, first thing we'll do is defer that event loop, event loop wg dot done. So this will run when the all the tasks in that event loop is done, and our event loop will keep on looping until all the tasks are done. I know that's very confusing to say, but that's what the event loop is. So let's go with for, and then we'll do a select. We'll select the task based on, so we'll go with case. It's gonna be of task, and let's assign a value to it. It would be from the channel that is our task queue. And if we have task in our task queue, then we'll just run task.callback. And next we'll just check for default. In this, for now, let's add a to do. Check for, let's add a to do, check for remaining tasks or close. And after that we'll just wait for few seconds so that all the event loop is done. So we go with time dot sleep, and it should be 100 into time dot millisecond. So we'll just sleep for 100 ms. This is the simulation of process dot tick, or you can be like event loop ticking. So every time in every 100 ms or 100 second, the for loop will keep on looping. Right, so we are done with our implementation for our for loop or the event loop. Now it's time for us to create a function to handle our async operations. So let's go with async operation. It will take two parameter, name type string and duration of time dot duration. Here we need to understand that the async operation could be of type any, that could be of database query, HTTP request, or anything. So we are not implementing that, but we are simulating that particular effect, like how long this particular function should wait. So for that, first we need to do is increment the WG counter or the wait group counter of the worker thread. Second, we create our go routine, and this go routine will be an anonymous function that will run as soon as this function is declared. So here we do defer wg dot done. So basically when this function is done, at the time it should just close it off. Now we go with fmt dot println, and here we say worker and processing, and it's processing the function name. Once this is done, now it's time for us to wait till the operation is done. So for that we just do time dot sleep, and we just pass in the duration. And now once it's done, right, we need a way to provide that we need to pass in data to our task queue that the function is done, you need to process it the next. So we just put it under the task queue and we'll pass it task, and here it will be a callback which would be nothing but a function, uh, and thus which will only pass fmt dot println, and it will be an event loop, and event loop will be like task completed and name. Let's add it in space so that it's easily available, and that's it. We are done with our implementation of our async operation. Now let's move on to the one of the utility function that we are gonna need is a wait group counter, so that we can keep count on the number of um, the event loop is running and all the tasks in the event loop are done or not. So for that we will just go with func wg counter, and in this we are not gonna do anything, but it's gonna return an int. So first thing first is that we will create a state. That state is again another wait group, sync dot wait group. Sorry, what happened? That's this sync dot wait group. Yes, I forgot this. Next we need to increment it by 1. So basically it says that the function has started executed. Now please mention that the event loop is running. We go with count and we'll set it to 1. Once it's done, we create another go routine. So this go routine will act as a placeholder or a function that will check for all the data or all the function inside a wait group is completed, and if it's completed it will reset the count to 0. So let's go with that. So once the function is done, and it's gonna be an quick function or ify types that it will run as soon as we hit this line. So it will be have state dot done, and inside this wg dot wait. So the wg is our original wait group for async operations, and then if it's true then we set the count to 0, and finally we return our count. Now we are done with the counter as well. Now we need to only add the last part, which is the main function, and run our event loop. Func main. Let's go with fmt dot println, and it will be, this is our main function which says starting event loop, and then we need to provide that event loop has one instance running. So we go with again, then we run event loop on a go routine. Now it's time for us to add all the async operations. So let's go with async operation. Let's first name it as a database query, and it's of 2 seconds, 2 into time dot sorry, it's not capital, it's small, time dot second. Let's add another async operation. It would be an http request, and it will only take 1 second. And last we add another operation which would be read file, and it's gonna take 5 seconds. Time dot second. Now we need to wait for all the operations in the wait worker threads are done. So we just do wg dot wait, then we do event loop wg dot wait, so that all the once all the worker functions are done, we should be able to wait for the event loop to finish executing the remaining tasks, and then we print ln, and it will be again main, and it should be all tasks completed, and it should be exiting, not existing, exiting. So we are done with the implementation, but One thing we should remember that when we created our weight group, we haven't or didn't use it yet, so we need to use the weight group also. So what's the use of this? So here in default, when there is no task in the task queue, we still need to check if task queue is empty and also the event loop counter is set to 0. So for that we do if length of task queue equal to 0 and wg counter equal to 0. If the both of the cases are true, then we set fmt dot println, and we mention that it's gonna be again, let's keep it small like we keep it before, event loop no task left. Just do that load task left. We already have an exiting once mentioned there, so that should be fine. And we do return. So as soon as we hit return, the event loop wait group will be done. That means the event loop has done completing all the execution, and finally we'll get to see this. So let's start by running our program. So let's do go run main.go and enter. So we have our event loop has started, read file started, database query started, and HTTP request started. So if we see, our first request that was done is HTTP query because it only had to wait for 1 second. Then next was database query, which is of 2 seconds, and finally we have read file, which is of 5 seconds. And that's it. That's all we had to do to get this thing running, and that's how the event loop is executed in the Node.js itself, which is not a JavaScript, it's a C++. But for now, that's how this is the basic implementation of it. So what's the final verdict? Is that Node.js is not a really single threaded, but the event loop that it runs on is single threaded. JavaScript runs on a single thread, but Node.js itself uses worker threads to schedule. And event loop is just a task scheduler and task manager. It doesn't do anything more than that. Hope this breakdown helps you understand how a Node.js handles concurrency, as well as if it's a single threaded language or not. And if you find this interesting, drop a like and a comment and let me know your thoughts. Happy coding.